All right, I think we're just about ready to get started this morning. Let me clear out a couple of these things that are my desk in the way of the camera real quick. A bunch of extra devices on my desk from some testing yesterday. That's there for now. Okay. Is the sound? Yeah, the sound is looking good, at least in OBS. Let me know if the volume is all right and everything. Tweak it if not, if any folks are here yet. So quick introduction. Hello, everybody. My name is Tim. I go by foamyguy on Discord and GitHub. In this stream, I'm going to be working on CircuitPython projects, and specifically, I'm going to be playing with the MacroPad today. So I have a project that I started a couple of days ago. I have kind of the very bare bones basics of it built out, and I'm going to build out some of the rest of the functionality to make it do what I want. I'll get into what it is specifically a little bit more in a little bit, but before that, let me just take a moment to explain to folks who might be new, if you've never seen my stream or you've never seen anything about CircuitPython before and you're interested in what that is. CircuitPython is a version of Python that can run on these tiny computers called microcontrollers. So this is the website for it right here, circuitpython.org. You can go here if you want to learn more. You can also go here if you want to download the latest version of CircuitPython for your device and download the libraries that help you do all sorts of fun things. The specific one I am playing with today, like I mentioned, is the MacroPad. So here's what the back side of that looks like. And then, of course, on the front side here, it's got a bunch of Cherry MX keys. So I got a bunch of keys put on there. And this device, it can run Python inside of it. There's a tiny computer in there. It can run a version of Python. And you can write programs to interact with the hardware that is present on that device. So you can, on this device, you can control things like the screen, which is up here. You can control the rotary encoder, this knob right here. And then, of course, you can also control all of the Cherry switches, so your program can react whenever the user presses buttons on this device. If you are interested in the CircuitPython project and you want to help support it, there's a couple of ways you can do that. It is an open source project. All of the development for CircuitPython takes place on GitHub, so the repo for that is right here. github.com/adafruit/circuitpython. So if you are a developer and you want to get involved, this is one of the ways you can do it, is by helping with development on the project or the libraries as well, which are written in Python. Another way that you can help support the project is by purchasing hardware from Adafruit. Adafruit is a hardware and software company based out of New York, and they are the folks who are primarily financially backing the CircuitPython project. They pay folks full-time to work on this project, to work on the libraries and foster the community and things like that. So if you purchase hardware from them, you are helping support the CircuitPython project. So that is one of the ways. And this device that I am working with today, this MacroPad device, this is a device that Adafruit created. So you can see there, Adafruit MacroPad. There are other folks that manufacture CircuitPython devices, but they make a bunch of them themselves. They also make a bunch of sensors and other doodads that you can connect up and control with CircuitPython devices. So let's see. Let me pull the chat back on top of my window here. Thanks, Dexter. My keypad only has 8 keys. Oh, yeah. You know what's funny about the number of keys is I bought the MacroPad and I bought like 2 different sets of the keys, and I didn't really think about it ahead of time. And the MacroPad, it's got 12 spots for you to put Cherry MX keys, or Cherry compatible keys. Actually, I think they're a different brand, not actually Cherry. It's got 12 spots, and I bought 2 packs of 2 different kinds of keys, but they were both 10 packs. So I ended up with 10 whites. I think I like the whites a little bit better because they are clicky. But I only have 10 of them, and so I ended up with 2 browns. You can kind of see under the clear keycaps there. But I definitely do relate to your pain a little bit on the number of keys there. As I was putting it together, I got to the 10th one, and then I was just like, okay, I'm out of keys. I got to find something else to do here. So thanks for tuning in, and thanks for the audio check there. I appreciate that. So Like I mentioned, I'm going to be working on the MacroPad today. The specific project that I have in mind is this sort of math problem practice application. So lots of the MacroPad projects that have come out so far, and of course I think lots of what was imagined when this device was created, as the name suggests, is for MacroPad type devices where you plug this into your PC. And then you can set up each of the buttons on here to be different macros to send different keys, either hotkeys or multiple keys together in a macro. You send those to the computer and you can use them to control different things. Hey there, thanks for the audio check on Twitch as well, Cornbread Ninja. But I'm going to take a little bit of a different approach from that. There's lots of great macro projects out there already. And I was actually kind of inspired by another project, which was not technically on a MacroPad, but it was, let me pull up the Learn Guide for it, actually. There's a great Learn Guide for it. This one was from Jeff Epler, which is one of the core developers that works on CircuitPython. Why don't we just go new? Maybe we'll find it in there, I think. So yeah, you can see there's a couple new guides related to MacroPads lately, but this is actually the one that was kind of the inspiration for this. And this is actually, it was a custom board that Jeff made. And it's not actually a MacroPad, it's a custom board. It's got more keys, in fact, getting back to the idea of different numbers of keys. This one actually has, 4 by 5 there. So this actually has 20 keys on it, which is nice because there can be a 9, a 9 pad, 1 through 9 plus 0. But then there's also room for like all of the, different math operators and some other stuff like clear and function and percent and things. This one is a calculator, so you can, use it just like a normal calculator like you would, punch in a math problem and hit equals and, press equals, and it will solve it for you. And I really like the way that this turned out, honestly. It uses a Feather, a Feather OLED screen at the top there. And as soon as I saw these numbered keys here, these 3D printed keys with the numbers on them, this was kind of the idea that came to mind for me was instead of a calculator where you punch in a problem that you want it to solve for you, we'll go the other way around. So we're going to have the program suggest math problems for us, and then it's the user's job to enter the answer to that problem. And then, it will tell you if you got it correct or not. Maybe it will keep track of how many you've gotten correct in a row. Maybe if we want to get extra fancy, it could keep track of like how long it takes you to answer them and stuff like that. So that's the basic idea of what we're doing. It will suggest a problem, and then you have to type in the answer. You can see I don't have the 3D printed keys yet. I'm just working with the standard clear keys. So we don't have those yet, but I do have in mind to create a couple of those. And I actually want to try some different techniques to make the two-tone like this. I think the way that Jeff created these two-tone keys is by using kind of like pause the print, like print a couple of layers, maybe 1 or 2 layers, and then pause, and then switch out the filament with a different color, and then resume the print from there. And so the first couple of layers are one color, and then the rest of the print is a different color, and it makes this nice contrast effect. I'm going to try something a little bit different, I think, but I haven't quite gotten around to that part of it yet. So we're going to work on the software for it today. What I have so far is really just the very basics of the screen and the number capturing from the keys. So you can see I've got the screen set up here. It's got a title bar along the top. It's got a placeholder right now. This is just a hard-coded string for the placeholder, but this is how I imagine it looking, is it will give you the math problem right here. And then as you type your answer, which I can press a couple of keys, you see there, it will put the answer that you're typing below, and then eventually you will press the enter key. And once you press the enter key, it will check and see if your answer is correct or not. If it was correct, then it will take you to the next problem. If it was not correct, maybe it'll give you another like 1 or 2 tries or something like that before you move on. And another thing I think would be really cool to do is on this MacroPad device, underneath all of these keys, there's actually a NeoPixel. There's a RGB LED underneath every single one of these keys, and you can access them all independently. So you can make them turn different colors if you want. You can run LED animations if you want. So I think it would be neat if when the user does get the problem correct, maybe we can have it play like a green animation. Maybe it will light up a bunch of these keys as green with some sort of nice, interesting animation. And if you get it wrong, maybe it will light them up as maybe yellow if it's your first try. That way to say, like, you have another try to get it right. And then eventually, if you still get it wrong again, maybe it'll go to red and then eventually move you on to the next problem. So that will be what I aim to do today, is work out the logic of actually asking real problems, checking real answers and stuff like that, and then maybe doing the LED animations on those keys there. So I'm going to go ahead and dive in here. I got, let's maybe rearrange some windows. I got Moo opened up. We'll put the camera over here. Maybe we will also scooch this over a little bit to make sure that it's not getting covered up by the chat or anything like that. I think that'll be good. Yeah. Go. Okay, let me shuffle the windows. Let's get the chat back on top. So I'll run through what I have so far. It's really basic at this point. I've got, the basic stuff like setting up the display. I am using the MacroPad library. This is a new library that came out just maybe this week or last week that just makes it easier to use this device. It's a library that's built specifically for this device to make it easier to use. Zoom in here, actually. A little big. It's possibly that's getting covered up by the chat. I'm not actually sure. Let's see how that works. It takes my screen here a minute to upload as well, or to update, I should say, rather. Yeah, that actually fits pretty nice right there. So let's run it this way. This library makes it real easy to interact with the hardware on this device. You don't have to use it, right? You could go and you could interact with the hardware, a little bit more manually by writing out the code to read the key matrix and read the encoder and set up the screen manually and all of that sort of stuff. But this library is nice and easy. You can just kind of initialize the library and it does a lot of that stuff for you. You can see, after I initialize the MacroPad, I am pretty much able to just access macropad.display. I don't have to worry about anything else, and my display gets automatically set up for me. The keys work the same way. I can just read the keys real easily, and the encoder, the rotary encoder as well. So I have the way I've set this up, I have a map. I called it numberpad map. Essentially, these are the actual numbers that represent the keys in the matrix. So the way that the matrix works out, it happens to be that this key up in the top left here is key number 0. The next one over is 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are the indexes of these keys. I did actually want my number pad to go kind of the opposite way around, though. I wanted it to be when you press this key right here, you get a 1, a 2, a 3, 4, 5, 6 in the middle row, 7, 8, 9 in the top row. 0 is down here in the middle, and then I've got an erase key and I've got an enter key. So erase is on the left. When you press erase, it will, backspace. It will delete what you have entered in case you made a mistake, made a typo, and you want to go back and erase it before you enter it. And then the enter key I've got set up on the bottom right. So when you press the enter key, that's when it will actually check to see if your answer was correct or not. So this map basically just maps those indexes to the values that I actually want to use for them, which are kind of like in a bit of an opposite order there. Next, I created a label for the title. That's this one at the top here that says Math Practice. And I think I just lifted this out of the simple test example, or one of the examples. I don't remember if it was simple test or not, actually. But I took that out of one of the examples in the MacroPad library. So it's got this nice sort of white background to make it look like a title bar up there. Next up, what do we have? We have the problem text. This is creating another label. And right now you can see how I've got the text just hard-coded right here to that 33 plus 23. I just stuck that in there as a placeholder so that I could see how big it was going to be and stuff like that. I will scrunch this just a little bit here. A little bit more of the text on the screen. Sorry, the camera seems a little bit wobbly today. I'm back on the bouncy ball fix, so try not to wobble it too much, but you may have to bear with me a little bit. In order to position this problem text, we're using the anchor point positioning. So, 0.5, 0.5, that means we want to place it based on the center of the text. And then what I did is also center it within the center of the screen, width-wise, horizontal-wise. And then I just have it 20 pixels down from the top to make sure that it's below the title bar. Next up, I have an answer text. This one is also just a label, positioned the same way with anchor text. And 0.5, 0.5 to get it from the center of the label. Also centered within the screen here by doing, the width divided by 2. And then this one is just 34 pixels down from the top. And this is the one that shows the answer as you type it. So I hit 236 right there. And that showed up inside of this answer text label. If you're familiar with display.io, you know that whenever you create a display.io object, you append it to a group. And then, of course, you would show that group on the display, which is what we did back up here. We created our main group. So anything that we append into that main group will get shown on the display. We put our two texts on there. And then we have next up our loop. This is sort of the main loop of the program. We do have a Boolean here that says pressed key. Is this still getting used? Yeah, it looks like it is. Pressed key. So this variable will get set to the value from the dictionary up here, from this mapping up here. It'll get set to the value that you actually pressed. So if you press the index 2, which is actually the number 9 in my program, then the 9 string will get stored inside of this variable. Of course, when we first run the program, nothing is pressed, so it does start out as none. And so again, that MacroPad library makes this nice and easy. We're able to just say MacroPad keys events.get, and that gives us back a list of all the keys that are pressed. We can then search through that list. We can basically say, if any of the keys are pressed, then figure out which key it is that's pressed. If it was the enter key, right now all we're doing is just printing the word enter. If it was the erase key, we're printing the word erase. We are also setting the answer text there back to empty. So that's why if I press the erase key here on the left, that my 236 up here will disappear. And then the other case here is the number keys. So any of the keys, 0 through 9, if those got pressed, then it will just basically append whichever key did get pressed into the text in the answer text. So that's why it, will build up more and more digits as I keep typing there. It's just appending the next one onto the end of that answer text. So that's really all I've got right now. So you can see essentially what we have is the layout, only the visual aspect of this. What we need to do is actually add the logic that's going to, suggest the problems for us to do and then check whether we got them right and all of that sort of stuff. So let's dive into that. I think one thing we're going to want is some state machine logic. Basically, we want this program to know what the current state is. Is the user waiting to answer a problem? Is the user having the problem be answered correctly or incorrectly? Those will be especially important if we do want to do the LED animations like I mentioned. I also have kind of designs on making a settings page. So I would like to make this configurable where the user can say maybe which kinds of problems they want to be able to do. They could turn on or off if they want, addition problems or subtraction problems and multiplication and division. And so I want a settings screen to control that. So we would have a settings state as well, maybe some other things. So I'm going to start with that, and then we'll just kind of build out from there. So whenever I make a state machine, I tend to just make a current state variable. We'll set that one to something. Let's call that waiting for answer, I think. Is that right? Yeah, I think we'll do that. Waiting for answer. So this is going to signify that we have asked a question to the user. We've asked them a math problem and we're waiting for them to type in the answer. Of course, we will need to make a variable for that as well. I like to actually start my state variables with the word state like this. That way it's real clear from the code that it is a state variable. So we'll make this as well, state waiting for answer. I'm just going to use integers, so we'll call that one 0. Maybe we'll make a couple others while we're here. Maybe state answer correct. Maybe state answer incorrect. What else do we need? Probably, we'll need a settings one, state, settings. Another thing I think it will be nice to be able to do from the settings is maybe manipulate the minimum and the maximum numbers. That way, like, if you only want to work with numbers like, 1 to 10 or 0 to 10 or something like that, if you're, a young student just starting out in math, you probably don't want to be getting questions like, 55 times 49 or something like this. So maybe you'll be able to limit it to only 1 to 10, or maybe you could choose the maximum and the minimum. That way you can kind of set this up based on the person who's using it, what their current skill level is. Do we need any other states? That's probably good for now. We'll come back and add others if they come up. So now, the core idea of a state machine essentially is, inside of our main loop, we're going to have different behavior based on what the current state is. So the current behavior that we have right now is pretty much going to become the waiting for answer state. So I'll just add an if statement right here. If the current state is the state waiting for answer, then we will go ahead and do this stuff here. We've already got coded in. Let's see, there's a tiny sleep in here. I don't know if we necessarily need that, but it's probably nice to go ahead and slow it down some. Maybe we'll take that out if we add animations, or we'll do a different one. I think this was in the example that I kind of started this from, so I've just left it there for now. It can help with things like making sure that the keys don't spam if you hold them down. In this case, it actually doesn't do that anyway because of some of the logic here. The way that the MacroPad library works, it only gives you one response when you hold the key down. It doesn't keep sending it over and over again. I'm sure there's a way if you wanted to know if it was held down, you could figure it out. But in this case, we really only care about single presses. We're not worried about press and hold. So I think, what should we work on first? I think we should make it ask the math problem first, because right now, again, I just have this example problem here hard coded. I think it'd be good if we make that choose a random math problem. So let's do that. In order to do that, I'm actually gonna also go ahead and set up a settings dictionary. Settings. We're gonna make this a dictionary. And to start with, I'm just gonna hard code the settings, but then when we get to the point of making the settings screen, we'll actually manipulate the values that are in here. So in the settings dictionary, I'm gonna say we will have a, let's see, what are all the settings gonna be? We're gonna have, let's see, we're gonna have one for each of the type of operators. So addition, maybe we could go, do we need uppercase? I don't think we do. Let's just go addition. We'll make this true. So this is going to be true or false whether or not you want it to ask you addition problems. We'll do the same thing for the other 3 types of operators. Subtraction, we'll make that true for now as well. Duplicate these, and then we'll change them out to multiplication, let's go the same. Multiplication. I spelled these things right. I don't know if mu has a spell checker or not. And then division. This. We'll also go ahead and put a min number. We'll make that, do we want to do 0 or do we want to do 1? Or do we want to do 2? Let's start with 0. We'll just do 0. We'll do a max number. And what do we want to start with as our maximum? Let's default to kind of like the hardest setting, if you will, and then if they want to back it off some, they can lower it down. So why don't we just start with maybe 100? That way it'll give us, you know, mostly 2-digit numbers for the majority of them. Do we need any other settings for now? I think that's probably good. These will be good enough for us to be able to generate our problems randomly. Let's create a couple other variables I think that we're going to need, like a first number, and we will just put it on 0 to start with. We'll create a second number as well. We'll put that on 0 also. Second number. We will create a operator. Of course, that's the name for the sign in the middle. So like, you know, either plus, minus, multiply, or divide operator. We will just default that to, I think, plus. We're going to change it when we generate these things randomly anyway, so it doesn't really matter what we set it to for now. Let's see, what else do we need? I think we'll make a function. Make a function def random problem. Does this function have any inputs? No, I don't think so. Random problem. So this is gonna do a couple of things. First thing it's gonna do is choose a random operator. And to choose a random operator, we basically are just gonna get a random number from, let's say 0 to 3. So there's 4 possibilities, you know, 0, 1, 2, 3. And we'll just correlate each one of those possibilities to one of the possible types of operators. I don't actually know off the top of my head the exact code for random. I think import random dot rand int. That seems relevant. Rand int. If we give that, nope, takes 2 positionals. And int. Takes 2 positionals, so it probably wants an upper and a lower bound, I guess. Wait, it doesn't like 2, does it? There we go, finally. Okay. I'm just running this a bunch of times to try to check if the bounds work, how I'm thinking. Different programming languages, sometimes the way these bounds work is like, you know, one of them is inclusive and one of them is exclusive. It seems in this case like they're both inclusive, because we did get 3 to come up a couple of times. We also got 0 to come up. So I'm guessing that's probably what we want. So we'll say, what will we do? I think maybe we could make an operators list that will match these up to their index. Let's go operators is a list, and this is gonna be, let's say, plus, whoops, plus, minus, yeah, thank you, that's the docs there, it looks like, including both endpoints. Yep, okay. Times the asterisk, or do we want to do the x? Let's go with the asterisk. And divide. Divide will be the slash, and that doesn't look like we need to escape it. I think the other kind of slash, if we wanted to use it, we would need to escape it, but like we're good there. So we'll basically say that we want to set operator equal to one of the values from this list, operators, and the one we want, we will get with random.randint 0, 3. We're going to need to import random. Okay, so now we should be getting a random operator. Next up, we're going to have slightly different behavior for division than we are for the other 3 types. Because essentially we don't want We don't want decimals. I don't have enough keys. There's no decimal input on the pad here, so with division, we're going to want to make sure that our answer is a whole number. Oh yeah, that's even better actually. Let's do that. Yeah. Instead of getting an integer and finding it in the list like this, we can actually just get a random choice like it says there. Is it rand choice? Random dot choice. Right at the top there. And we can just give it the list and it will pick a random one for us. Yeah, good call. Thank you, Dexter. Operators. Yeah, that's more clear. So we're gonna say if it's not division. So for addition and multiplication and subtraction, all three of those are going to work the same way. Oh, actually, are they though? No. Subtraction will need to be different as well. Yeah. Because we also don't want negatives. We don't have a way to type a negative sign, so we don't want the answer to be negative. Yeah. So actually, let's say if operator in, we'll do it this way. If operator is in plus and multiply, then we'll do it like this. Else, actually, we'll go elif operator is subtraction. I'm just going to put a pass in here for now. We'll come back and fill it in later. And I'll do an elif. This one could just be an else, truthfully, but I kind of like making it an elif so that the code is more explanatory. So this way we can actually have a nice clear, like, yep, it's definitely for division. We can tell because it says right there if it's equal to division. It would work the same if we put an else, but that's all right. Finishing up my coffee for the morning here. Okay, so plus and multiply, these are the easiest two. We basically are just going to get random numbers for both the first and the second number. So first number is equal to random.randint, and we'll say settings.min number and settings.max number. Well, not dot, actually. I guess we have to access it with the square brackets there. Min number and settings. So then I went ahead and put the dot anyway. Max number. Just split this down to the next line just to make it so it's visible all on one screen here. Okay, we'll do the same thing for second number. And now we will, so we have our operator, we have our first number, we have our second number. I think those are called operands maybe, but not actually sure. And I like first number and second number better because I think it makes the code easier to understand if you don't know the right terms for math. I think we can just go ahead and stick it into the problem text. So we can say problem text.text equals, and we'll just build up a string here. So we'll use string formatting maybe, or you know what? I don't use f strings very much. Why don't we use an f string? So when you use an f string, you put them inside of here, I think, right? So it would be first number, and then we want operator, and then space second number, and I have an equal sign there as well, right? Yeah. So we'll go space equals. Doesn't really matter if we have a space on the end. I don't know if I did the f string right. We save this, does it run? It does, okay. Why these are white? Not sure if Mu actually knows about f strings. Maybe it's a little confused by this. So what if we said, right before our main loop, what if we test this out? And in order to test this out, I'm actually going to turn off the randomness for just a moment. We're going to say, we're just going to hard code it. Operator equals, we'll call it plus. And we'll make sure this works. Right before our main loop, then we'll say, what did I call that? Random problem. Call that function. So now it should be not 33 and 22. Or I guess it could be if we just got lucky, but we did get a different one. We got 45 and 31. I'll run that a couple more times, just make sure we don't see anything super crazy, but it does look like everything is fine. Okay. So let's hard code multiply also, just to double check that this works correctly. I don't see any reason why it wouldn't, but yep, looking good so far. Yeah, okay. So I'll leave this here. We're gonna want to test out the next ones of these as well. So we'll set this up for minus. And in the case of minus, we want to make sure that we don't end up with a negative answer. So we want the second number to always be equal to or lower than the first number. So we're going to cheat just a little bit. Instead of being completely random, we are going to, how do we want to do it? Let's say, let's generate both of them, and then if first number is greater than or equal to the second number, then we are done. We don't need to do anything else. We can just go ahead and set the problem text. You can actually just copy this logic from here. But else, if the second number was actually larger than the first number, I think what we'll do is just switch them around. So let's go, we'll make a temp variable. Temp number is second number, and then second number is first number, and then first number is temp. So we'll basically just swap them right around. That way the bigger one will then be in the first number. And then once that is done, we'll do this. We could probably make this if statement more efficient. We don't necessarily, we could avoid repeating this code here, this line that's setting the problem text. I'm going to leave it for now just because I think it makes the program a little bit more clear, especially for folks that are not necessarily as experienced with programming. So I try to, especially with CircuitPython projects that I intend to share ultimately, I try to make the code like very, very explicit, even at the cost of a little bit of efficiency. So I think that should be good. Well, let's try this one out. I've got minus hard-coded, so we will definitely end up on minus. Oh. Interesting. You can just switch them around without a temp, because you can do it all in one statement. Let me try that way. I didn't know. I've seen like destructuring, and actually I don't know if Python has that. That's a JavaScript thing, I guess. I'm not sure if Python has that. So you can just go. Let's try it that way. first number, second number, and then just swap them around. Second number, first number. One thing I see is we did get a minus. Oh, you know what? I didn't save. That's why. Let's save this. Okay, so the second number is smaller. That's good. I'll just start this a couple of times. Make sure the second number is always smaller. You know, one other thing I might do actually while we're here to test this is I might just put a print statement. Print swapping values. This way we'll just see that the logic actually is getting fired or not. Yeah, this time it did, so we should be good there. And eventually, if we restart this a couple of times, we'll see one where it does not swap the values. Like this one here, did not print swapping values, therefore we know that they got generated in the order that they eventually showed in. So that seems to be working fine. Now for division. And in this case, we want our answer to always be a whole number. So I think what we will do is generate two random numbers, multiply them, and then swap out one of them with the answer from the multiplication. That way, and actually we don't just want to swap out one of them, we want to swap out the first one. That way we'll get the answer from the multiplication as the first number. The original second number can stay the same. And then the answer, the correct answer, will then be what we actually generated as the first number randomly. So we'll generate both of these. Don't need pass here anymore. Oh, I got an S. Did I get an S? I'm not sure. Oh, from pass. Which we also don't need. Let's see here. 1 second. Okay. My turn to play a word. Yeah, that's fine. That later. Okay, so we generate them both, and then we want to multiply them. So we're gonna say answer. Well, actually, let's call this multiplication answer, just to be a little more explicit. Equals first number times second number. And then we're gonna go and say, after that, the first number is equal to the multiplication answer. Is that all we need? Might be all we need. I think that's all we need. So then we can go ahead and set the problem text. I don't really like the way it's doing this white stuff here. Seems like maybe Mu does not know about the F strings. Of course, my version of Mu is actually quite old at this point as well. Maybe the newer ones are better. So let's hardcode division and make sure that's working. Does that work out? I actually don't know the answer to that. It's I wish this was not called calc. Later. I could use Mu 1.3. We'll take a detour and try to get that installed. But does this work out? 615, 41. Is that a whole number? It is. Okay. Cool. Let's just do a couple more and make sure. Yeah, I'm guessing that one is. So division is going to be probably the hardest one here, especially, I guess, for me mentally. I'm not so great at two-digit division mentally. 6 over 1. Yep. So this would be a good tool for me to practice actually division. Seems like we're okay though. Yeah, so I think this is probably fine for our random problem function. Seems like all the different operators are working okay, so I'm going to take out my hard coding. I'm going to go back to a random operator. I'll just let this run a few more times here so that we can verify it's still working fine with the random operators. It does appear to be so far. Okay. So what do we need to do next? Next, we want to check the answer that the user has typed in when they press the enter key. Let me see, actually, though. It might be nice. I mean, it's not a huge deal, but I would like it if the F strings would look good, and I probably should have the newer mu anyway. Let me see how quick and easy it is to install that. If it turns into a bit of a rabbit hole, then I'll just come back to coding, but I don't remember actually how I installed this. Sudo apt, say search mu. Problem is it's not exact. The way to make it exact. MNO. So many things that were not even on the first page. It's using regex, I'm pretty sure, is the way you have to make it exact. And I don't know. I don't know regex off the top of my head. We need a $, I think, and maybe an up caret or something like that. Apt search. Oh, yeah, you can see I've done this before. Ah, I was right. Yeah, up caret first and then $sign at the end. So we could say... Of course, I don't know if it's going to be just mu either, though. It might be more than that. Bummer. So what if we said... download from mu.com? Can't work so many things. I understand why some of these got counted. Like, what? There's no mu in this. New editor is installed. And it just says installed. So yeah, current version on apt is 102. So we do probably need to download it from the website. I will say I've gotten more used to Linux. I don't know, I'm probably not quite to a full year of using Linux. But one of the things I will say that I do not care for so much about Linux is there's tons of different ways to install things. Like some things you can go to the website, download it, and install it. Some things you have to use apt. Some things you have to use pip. Some things you have to use like snap installer or something like this. There's so many different ways, and I can never remember which way that I installed any given program. Looks like pip is probably what we need here. So why don't we close this? Let's go sudo apt move new editor. It's going to uninstall it. I need to run upgrade as well. Save that for later. Pip search new editor. Oh, right, pip search doesn't work right now. We want beta. It's the release version. No, 3 is the release version. I think I do actually. I'll go ahead and use the beta one. And does it show up in here still? No. I have to launch it this way. So I would need to make desktop .app thing or something. There's somewhere I can go make a shortcut that runs a terminal command that will make it appear in my applications, but or maybe we'll let this thing do its first time setup here. Maybe it'll do that for me. That'd be really nice. I'll have to figure that out at some point because I don't prefer to have it in the application menu. Or really, I had it on my start bar actually up here, so get it back there. That's what we want. I can make just a shell script or something for that. So let's see. We would like Python. There we go. Still have white here. I don't know if I something wrong. Is there supposed to? Are there supposed to be no JavaScript? Hey Johnny. Good morning. Well, morning for me. Yeah, I know I always say good morning and then I don't actually know. Might be, I think it's maybe afternoon for you. But anyway, thanks for tuning in. Ah, nice. Summer. Got some nice weather outside. Johnny's on vacation. That's pretty cool. Let me just search strings. I think my syntax is right. It seems to be working. But I don't actually use these very much. Just, well, I'm wrong. Strings. That doesn't come up. Oh well. We'll just deal with it for now, I think. It's good to have the latest version, though. So try out some of the new stuff. So we want to check if the user got the answer correct. Oh yeah, that is looking pretty nice. Nice and sunny. Not too hot, I don't think. My Celsius temperature, alignment, I guess, or whatever, calibration for Celsius temperatures is not great. Oh yeah, you're probably right. Yeah, with the light theme, it doesn't do that on them. Good call. I do like the dark theme better though, and I'll take the white F strings over the white everything else. 86. Yeah, that's not too bad. It's getting up there, but not quite in the scorching range. Yep. Yeah, we're getting up into the 90s Fahrenheit. Couple of days around us. Yesterday was actually pretty nice though. Went for a walk yesterday morning and it was actually pretty cool out. It was real nice. So let's say when the enter key gets pressed, we have in our if statement already right here, we want to check if the user got the problem correct. So we are gonna compute the answer. Problem Let's see, actually. We need to... I could use, like, execute, like, the Python thing. This is not really the greatest practice, though, because executing code, which is not necessarily secure. In this case, we're only importing numbers, so it wouldn't be that big of a deal, but I think it's probably best if we don't rely on that. So what we need to do is actually, we need to have an if statement. If operator is plus, then oh, I see. I have 3 characters. 1, 2, 3, 4. No, it's still 4. But weird to me for some reason. So if it's plus, then the problem answer is first number plus second number. Elif. No, this is out of alignment. Okay. Somehow I ended up with 3 Elif. There we go. Somehow I ended up with 3 spaces as one of my tabs. Operator is minus. Then problem answer. Copy paste that. First number minus second number. It's hot. 40 is fever. Oh, I got you. That's a good good rule of thumb. Here, Doc and Doctor, how's it going? Thanks for tuning in, both of you two. Problem with the dark theme, yeah. So next up, we'll just run through the list here. If the operator is times, yeah, I definitely agree with that. I can't. Give me that 3 spaces again. Go. I have trouble sleeping if it's too hot for sure. I'm a cold sleeper. I need it to be cold. So this one's the same thing, just minus, or excuse me, not minus, but multiply. And next up, this one, I think we might need to do integer casting. Because I think if we do division, it automatically goes to a float. Is that right? If we said like 45 over 9. Yeah, we got 5.0 instead of just 5. But because of the way we did our division, we know that we're going to have a full number. So we can actually just cast it to an int, which, let's do it like this, I think. Yeah. Okay. And I guess what we'll need is, we need a string. I guess we could just convert the text that's in our answer text to an int instead. So next we're gonna say if int of answer text.text is equal to the problem answer, print correct. And we'll come back and add some more fancy some more fancy features here, maybe like the LED animations I was talking about before. For now, though, I'll just print correct, and then maybe we will also generate the next problem. Else, if the answer is not correct, we'll just print incorrect. Hey, nice. Thank you for making that. Thank you for making that issue. It's over here. Not killing the chat. Oh, right. I can't do that, can I? Back here. What is the editor? Hey, person in the Twitch chat. I'm not gonna read your name off with all due respect, but the editor I'm using is Mu Editor. Let me put the chat back up as well. Discord chat. Where are we at here? Let's copy this. Got too many different browsers. Or did it work? It did work. Oh no, it didn't. This is the old thing. This is the thing I was looking. I can I'll put a screenshot as well. We'll go like a little bit more just for some context. Okay. Maybe we'll look into this, actually. One of the things that I've never done is work on any of the code inside of Mu, but I kind of have always had in the back of my mind that it would be cool to do a little bit of work inside of that editor. Maybe I don't actually know how the interface works or anything like that. Maybe we'll dive into that a little bit and see if we can't try to improve that one of these days. See you, Johnny. Okay. So, where are we at here? Is this gonna be working? I think maybe this is gonna be working to check our problems. So let's go ahead and run this again. So I'm gonna save it, and we're in the REPL right now, so I'm gonna go back to running the program. We got division, but this time, luckily, I do actually know the answer to this one. This is an easy one, 85, so type in 85, we will press enter, and we got incorrect. But it is actually correct, I think. So it's not quite working right. Let's add some print statements. Print, we'll print both of these things. Oh yeah, that would be super cool to have Circup integrated visually inside of Mu. Yeah, that would actually be awesome. You know, it would be like next level is if it would notice if your imports, like if you didn't have it on your board, and it would just prompt you like right in line there or whatever and say like, hey, do you want to install this library? But even if it was just a panel inside of here, like another button, and it was a panel and you could kind of like, you know, visually click through and add stuff, that'd be really cool. Okay, so we're gonna print these things and see what they are currently. I think Scott always says he's a print debugger. I am the same way. When in doubt, just start printing stuff out. Print both of these and let's see what they say. 34 plus 10, so that one is 44. Enter. Okay, so the second one printed 0. Which means that problem answer was on 0. Why would problem answer be on 0? So operator, operator is plus. You know what the problem is that first number, let's add one more print statement here. First number and second number are still 0 because my my random problem function did not make them global. So while I have inside of this function, I have like first number equals rand int, it's not actually changing this variable first number. It's making a new variable that's only inside the context of this function. So we need it to be global, or the other thing we could do actually is if we had a dictionary, then it would work, but it would also make the code a little more verbose. I think I'll make it global. Or if Moo could read the REPL in a useful way, like detect a missing module exceptions. Oh yeah, that would be interesting. Okay, if it could like read the error that you got and offer even more like help to you, like if it notices that it's a missing library, then it could just go ahead and prompt you over into the CircuitPy panel or whatever. Pretty sweet. Yeah, let me add a print statement. I'm pretty sure that's what's happening though, is my variables are still 0 because of that global issue. So let's just go print. Let's go print first number. This is not really the best way to do this with pluses, but that's all right. Okay, we got a tough one here. Is that 5? I think it's probably 5. 5 times 40 would be 200. 5 times 2 is 10. Yeah, I think 5 is the answer. Oh no, we can't even do it this way. Okay, so we'll go back to F strings. -65 minus 23, so that's 42. I think. No, 30. 32. No, 42. I expose myself here as not so great at mental math all the time. That's all right though. Yeah, 0 and 0. That is the case. So I think we need inside here. We actually just say what? Global first number, second number, operator. What we need to do. And this is not necessarily the best practice ever to use globals like this, but I think in this case it will solve the problem for us. 5 plus 22, that's 27. Ah, yeah, there we go. Yeah, now we got it correct. So let's also do one incorrect. You know what I noticed is that after we got it correct, we called random problem, which created a new random problem on the top row, but it left our old answer there. We actually want to blank out the answer as well. So let's go answer text dot text is empty. That way it will get rid of the old answer also. This one's pretty easy. We got 0 times 83, so that's going to be 0. Oh, but we wanted to do an incorrect. That's right. I guess we want to test our new code as well. 42 times 37, so that's, let's see here, 42 times 30, that would be something like 1,200, I think. So 1,200, and then 7 times 42, that's going to be something like 280 plus 14, 94. So 1,200, so 1,400. 94? Do that right? I don't think I did that right. Incorrect. And I also notice my prints here are giving me the correct answer, which is helpful. But the incorrect, this logic is working correctly, for lack of a better term. It's correctly figuring out that my answer was incorrect. So another thing that would be nice, I think, is in the case of an incorrect answer, I think we should also blank out the answer text. So let's go ahead and do that as well. Oops. We'll keep this consistent, put the stuff after the print statement. That one's pretty easy. So let's get this one incorrect and make sure that it blanks out the text correctly. So the actual answer should be, I think, 17. So let's put something different. Let's just say maybe 14. Yep. Okay. I think it would be nice if we had one more label on the screen that would have the results. So maybe we'll put it down at the very bottom and it will actually say incorrect or correct. So let's add a label to do that. Let's see where we'll just put it right alongside where we set up our other labels. You can copy this because it's going to be a lot of the same stuff. This one is result text. Anchor point, let's go midway in the x-axis, but bottom in the y-axis. And then let's say we still want it centered horizontally, so we'll leave width over 2 like that. And then next up, we can go at the bottom of the screen. MacroPad.display.height. And why don't we just give it a couple pixels of margin as well? So let's say maybe 4. And then right here we can say result text.text equals correct. Why don't we put a smiley face also? And when it's incorrect, say incorrect. And I don't know if we have enough room for it, but let's try to say try again. This probably should not be comma if try is going to be capital, but that's all right. Okay. 45 times 23, so let's see, 45 times 20, that would be 900. 45 times 2 would be 90. So 900 plus 45 times 3, that's 120 plus 15, 135. 900 plus 135 is 1,035, I think. You know what? We created a result text, but we never added it to the group. We're gonna need to do that. I did get it correct though. This one is add the result text to the group. There we go. 67 minus 17. That one is 50. Okay, there we go. So we got our correct there. It's much higher than 4 pixels. Maybe the display doesn't go quite as far. Seems like. Let me try with no margin. Seems like there's plenty of room there. That the reason why I put the margin, I didn't want it to be like on the very edge of the screen, so it would look weird, but it looks like there might be margin built in. Let's try not having any margin there. 27 times 32, so let's see. 27 times 30 is 600. And 7 times 30 is 210, so that's 810 plus 54, so 864. 864. Got it. Let's get this one incorrect so we can see it do the other message. So 82 minus 22 is going to be 60. So let's put something different. Let's say 50. Correct, try again. And that does fit on the screen, so that's nice. And then let's get it correct this time. So let's say 60. Correct. Next thing we should do, I think we should not just leave this here indefinitely. I think we should have it go back to blank after a couple of seconds. So let's say, how do we want to do that? Let's say, let's create a variable called answer time. Answer time. We'll start with 0. Actually, we'll start with -1 to show that that's like the default value, has never been changed ever. And what we'll do is when this gets answered, so when they press the enter key, we will say answer time is equal to the current time, which we get with time dot monotonic. And we will also have some logic that says if answer time plus time dot monotonic go in seconds or milliseconds, I can never remember. Time dot monotonic goes in seconds. Okay. So we'll say answer time plus, let's say we want that to stay on the screen for maybe 3 seconds. So if the answer time plus 3 seconds is greater than or equal to the current time, you know what we should also do actually is make a current time, I think. For time. Default also to -1. We'll set that as the first thing. This way we're not calling time.monotonic at different points in our loop. That way we have a static time. Like there's one exact time that it was the entire time through the loop, and then next time through it gets a new one. It's not going to probably matter that much for this case, but sometimes if you're calling time.monotonic 20 times, I mean multiple times I should say, you might not be expecting it to change throughout your loop. Like your logic might assume it'll be the same, so it could lead to inconsistent results. So we'll set this once, and then we'll say if the answer time plus 3 seconds is actually we want less than That's less than or equal to the current time. Then we will set result text back to empty. Yeah, I think that should do it. Let's save that. Let's run it. Oh, that's a toughie. I don't know that. So we're probably going to get it wrong. 5928. Okay, so we probably, our number probably ends with a 1 because we got an 8 in the one spot and we got another 8 in the one spot there. So maybe 31? Is that big enough? 41? 51. 6 times 7. I'm gonna try 51. Correct. Oh yeah, I was off. 76, in fact. Right, because the 6, oh yeah, it doesn't have to be a 1, right? Because the 6 times the 8 gets you to 48, which gives you the 8 in the one spot there. Yeah, I actually do tend to call that now as well. Think of it. More concise, let's do that. I like that better. I don't know why current time came to mind. And it did disappear, so that's good. We can, let's save it since we changed the variable name. Shouldn't make any difference, but 82 times 78, no, not times, minus. 82 minus 78, so that's only 4. Got it correct. And correct should disappear after a few seconds, and it does. Let's see. Another tough one here. I'm guessing this is maybe in the 30s? 30 something? 30, let's see. 4, 5, 6, 36? 28, wrong again. Go. Hey Johnny, welcome back. You must be close to the store. All right. So this is working how we want. I think the next thing we will work on, instead of just exposing how bad I am at division, let's work on the animations. I think it'd be really cool if we light up a bunch of the LEDs when the user gets it correct or incorrect. We'll do a green animation if they got it correct. We'll do a red animation if they got it incorrect. So for that, I'm actually going to take a step back out of this CodePy. I'm going to save this as a different file name, code math practice. Yeah, definitely agreed there. You know what would be cool is if you got this math practice tool and you got one of Jeff Jepler's calculators, then you can just do the calculation on the calculator if you don't know it. That'd be kind of fun to have both of them. Kind of defeat the purpose a little bit, but a lot of fun nonetheless. So I saved this as a different file. That way we have a copy of it. I'm going to go back to my CodePy and I'm going to blank this out and I'm going to just play with some animations to figure out which one I want to use. This way we don't have to worry about any of the calculator logic and we can just work on animations by themselves. And then once we get it all figured out what we want to do, then we'll bring the calculator code back and we'll paste this logic for LED animations into it. So wow, that was, I think, the longest I've ever waited on search results there. That was interesting. Maybe my internet hiccuped. Well, a hint. I like that idea. I like that idea. Wonder what would be the best way to give them a hint. Maybe like give them the first digit or the couple digits or something. Interesting. Okay. Let's see. I do not probably have this library on my device yet. Guessing. No, not yet. So I'll use Circup. Why don't we use Circup? We were talking about that earlier. Gotten more in the habit of using Circup. Go here for now. Oh, what is this? Oh, this is running my Mu instance here, so we don't want to close that. Let's make a new one. Circup install. Go. And I don't want blink. Let's see what comment looks like. I'm just gonna play with a couple of these until I find one that I like. Oh yeah, LED animation library is really cool actually. It's makes it super easy to achieve like relatively complex animations. I really like it. Pixel pin, I'm guessing is probably board.neopixel. Yeah. That. I copied it. Or I think I copied over it actually. Not working. Can you not shift Control C? Or shift it's unhighlighted. Does anyone who uses Mu on the later versions, does anyone know how to copy out of the REPL? It used to be shift Control C. I guess I can. That's what this says. Maybe the order matters? Control shift? The order does matter. Which is a bit of a bummer for me because that means that I can't use my MacroPad. Well, not my macro. This device is called MacroPad, but I have a different macro device that I use that has macros built into it. Oh yeah, that's true. Making custom ones is relatively easy as well. Nice. Yeah, 3 blocks. That's really nice. Yeah, I'm maybe like 10 minutes or so by car from the grocery store, and just go like straight down the main road that we live off of. Okay, so that should have copied. Let's see here. I paused on us back running here. Okay, this is our pin NeoPixel. We have 12 pixels. Things tend to be pretty bright, actually. I usually start at 0.1 and go from there. I don't know what that was. Okay, so let's try running this. Actually, do we need to change anything else? Let's see, we have 12 pixels, we have the pin. Color Jade. We'll try it like this. Let me pull the camera back. I don't know how well the lights will come through on the camera. Valid syntax. Oh, what happened here? Oh, I have pasted this a bunch of times. Okay, let's fix this. Get this. Let's type it. There we go. That's pretty. Oh, I didn't put the camera back. That's pretty cool looking. One thing I do want to do is this green color doesn't look exactly the same on the camera as it does in real life, just because of the difference in light and everything, but it is a little bit of a kind of pastel green. I think I want like full-on green. Let me take the brightness down too. It's actually not too bad because the keycaps diffuse it quite a bit actually, so not as bright as I'm used to seeing on pixels. But let's go with green, like all the way green. And I don't know, it's hex or tuples, maybe both? Or either, I should say. Right, like this. Of course, that was blue though, not green. Yeah, that's what we want. This is pretty cool. It's basically going like, it's going in order, like this pixel, then this pixel, then this pixel, this one, this one, this one, this one, this one. Which gives it that nice back and forth effect, but it kind of looks like it's going back and forth on a diagonal. I think it'd be cooler if it went just straight up and down, maybe? I'm pretty sure there is either an animation that does that, or there's going to be a way to do it using, I forget what it's called, but you can basically treat like multiple pixels as one pixel. Yeah. A group. It's the group here. Or if a group is one, actually. Yeah, no, I don't think so. A group is meaning like running multiple animations on different sets of neopixels. Like if you had like two strips, for instance, and you want to run different animation on both of them, or you wanted to run like the same animation on both of them, but they were connected with different pins. That's what group is for. So that's actually not necessarily what we want. Pixel map? Yeah. This is more like what we want. Yeah. Okay, let's grab this one. Just the code though. I have 12. I want vertical as far as the orientation of the board goes, but I don't know if that's the orientation of the pixels or not. So we'll just kind of comment some of this out. We'll try it out and see. So this says vertical lines, 8, 4. Pretty sure those are not the numbers we're going to need to use. It's probably 3, 4, guessing. Map 8. Let's look at the docs. So this is what? This is a pixel map, vertical lines. These are not in the in the docs. Let's go with the learn guide, actually. There's a good learn guide for this. Yeah, this is like what I want, actually. How it is in this, where it's like doing full rows at once. I want it to do that, but I think going up and down. So it's pretty similar to what I have now. It's just doing an entire row at once instead of only one pixel at once. Let's take a look. Yeah. Okay, so this is exactly what we have. We have pixels arranged in a grid. Visually, like when we look at it, it's a grid, but in the actual circuit, it's one big sort of snake type thing there. It's going top left all the way to the right, and then back around and over again, and back around and over again, and back and forth, back and forth. So we want to use a pixel map. And let's see. They're not the lines in the grid are running alternating directions. So we'll have to figure out if that's true for the MacroPad or not. I'm not. Actually, we can tell that, actually. Why don't we take what's running now? Go back to here. Slow this down a little bit. Speed. Say okay. This actually does allow us to tell that these are not going in like alternating directions. It's always going the same direction. Starts on the left in the next row. It starts on the left in the next row. So on and so forth. This one's going backwards as well. The comet is flying back up. But when it's going in each direction, it's always starting on the left. So we would have alternating false. We're going to pass it the width, which is 3 pixels. And then the height, I guess, is the next thing probably, which is 4 rows. So is there a full breakout here? Yeah. I think this actually, though, this looks like the same. This looks like the same. The one we just copied. Start with this. So we're going to cut some of this stuff out. We don't need too much of this. I'm just going to stick with Comet, I think, because really what I want is, I think I want it to fly down throughout the rows and then maybe back up, and then that'll be it. And then it'll do red if it's wrong, and green if it's correct. I don't really need any of these. I'm not going to be doing a sequence. I'm only going to have one animation. I don't need any of these colors. I'm just going to use full red and full green. Just going to kind of cut out stuff we don't need. Pixel, this is 12 pixels. I am still not sure if this is technically going to be vertical or horizontal, so I'm going to leave horizontal for now, and we're going to test vertical. We're going to make a comet. We're going to go green. Oops. Tail length, let's do 2. Bounce, I'm pretty sure bounce means that it's going to go backwards the other way as well after it gets done, so let's leave that on. They do actually have Comet B and Comet H. Let's comment those. Maybe we'll try them if this doesn't work. Don't need Rainbow Comet or Rainbow Chase. We don't need any of these. We're not doing a sequence. And we just want to go our single animation. Oh, I see. This is Comet V. I see. Okay, and I actually did those backwards, didn't I? Let's just switch them around, I think. Let's call this Comet V. Let's call this Comet H. Paste this in here if we end up using it. Okay, let me get the camera back. Frame here. I cut something out that we needed. Let's see. Or something. Let's see what we did wrong here. Ah, yes, this is still on 8. So the width of each row is 3. Height of the number of rows is 4. And I'm guess this probably needs to be 3 as well. Oh, right. Comet V. Okay. So yes, that's pretty much what I want, but two things. Let me cover this up somehow. Let's cover this up. Let's cover this up with this. Is it actually lighting up the bottom row? Yeah, it is. It is. Okay. But I want it to go the other way. So I did guess wrong on vertical versus horizontal, so let's switch those up. Okay. And we'll need to fix some more stuff, like put the color. We don't really need 6 as the tail length, though. We want to go shorter than that. Bounce I'll leave on. It's down to the next line so that we can see all of this stuff here. So change these. Yeah, that's what I'm after right there. It'd be nice for the tail to be a little bit bigger. Let's try 3. Yeah, I like that. So again, I know the it doesn't come through so great on the camera here. Maybe if we turn the light off temporarily, make it a little easier to see there. It doesn't like to focus as much, especially on screens without the light, but yeah, that's pretty cool. So I think what we'll do is we'll have it, you get a correct answer, it'll go down once and then bounce and go back up once. So it'll kind of sweep down and then back up. And then it will stop. So how do we make it stop, actually? Let's go... Guess we would stop calling animate. How do we know when it's done, though? Not actually sure how do we do that. We want it to just run once. Look in here. Or speed. See what this says in here. I've used this library before, but not that much. Mostly just for testing examples. That. So I'm not super familiar with all the ways to do everything, so excuse me while I kind of learn a little bit about how to do it here. Cycle. Reverse. Reverse the same thing as bounce, or are those two different things? Let's also get the, let's go back to the docs as well. Why don't we just look at the docs for the comet example? Or the comet animation, rather. It does have reverse. Okay, yeah. That's just makes it go the opposite direction. So I guess it would probably start from the bottom and then go up to the top. But I think it makes more sense to start at the top and go to the bottom because the screen is at the top. We do want it to bounce. Ring mode. I don't know what ring mode would do. Said. How do we make it just run once? I guess we could. We do that. We could use time, I guess. Like, we know speed of the animation. I think that's really what we want. So, might not get the timing exactly right. Let's look at animation group. I guess we could maybe put it in a group with another animation that will turn it off. Members. Can we find out which member cycle count? Yeah, this seems pretty relevant. Cycle count. On cycle complete, even more. Of X property. Okay, let's look in the code also. Oh, you know what we could do actually is, sorry, I go on tangents sometimes. This is a PR. I tested this PR a while ago. There's a little bit of outstanding work, but I think the original author might not be coming back to do it anytime soon, at least. We'll finish this up one day, even today. Let's see. This is it is a really cool PR though. It allows you to have a mask where you can have like different animation running on the part that's masked versus the part that's not masked. So you can do things like it's making a heart here as an example. But it could actually do a lot of other really cool stuff too. So it'd be nice to get this merged in. Maybe we'll try on finishing that up one of these days. Let's look at the animations. Let's look at Comet and see if it calls on cycle. Does. Well, it has this as true, I guess, at least. It does not have anything else though. That cycle complete. Setting that to true. Set to the first state. So can we say if comet dot cycle complete not? Will this make it run once? Save it? No. Oh, comet H. Probably change that to just comet once we get back to the actual code. It is interesting that it busted me all the way out to the REPL. It seems like that's changing. Bounce is changing the behavior of that. So I mean, if we print cycle, it's just gonna print false over and over. Yeah. Back in this code again. So let's see. What if we turn off bounce? It looks like no. These reverse equals initial reverse and draw count greater than 0. So draw count, maybe draw count could help us as well. What if we print that? Yeah, this is continuing to count upwards, so we could find out how many draw counts equals one cycle. Let's do that. So what if we just start by saying, oh, sorry, I didn't have the camera back there. So what if we said, if the draw count, would it be 8, I think, because there's 4 rows. Each row is one drawing, and then the reverse is back up for another 8, or would it be 9 maybe because of the tail? Let's try on 8 and see where that gets us. If the draw count is less than 8, less than or equal to 8, see what that does. Okay, so that ran all the way down once. So if we did 16, then it would go back up as well. Yes. Okay. And that's what we want right there. So it ran once down and then bounced and went back up. And so it does not want to let me, interesting. Not want to let me break out to REPL. Maybe it's unhappy with, no, it's not letting me do anything in here, actually. Huh. Why don't I think maybe this, right, and I can't change anything though. Let me unplug this, I guess. Plug this. And let's, can I do stuff now? Can't use the arrow keys. Can't type. Close Moo and reopen it. The X button doesn't work either. Open it. Can't find the device because I unplugged it. Arrow keys work and my typing works, so turn it back on. It's good now. Not the right key. It is letting me change stuff though, so that's good. So what if we don't print, I think? I suspect this is probably unhappy with how fast it's printing stuff back into the serial console. Maybe we'll also put time dot tiny little sleep in here. That way it'll give it a chance to do some other stuff. But it didn't run. Time is not right. Let's do that. There we go. Don't know what that was, but looks like we're good now. So the one other thing we need to know is if we call reset, will it reset the draw count back to 0? I'm just going to look in the code, try to confirm that. That seemed like it. But it's not actually ever updating draw count inside of here. So it must be happening, I guess, inside of animation. Why don't we just try it out? So let's say else. For now, I'm just going to go sleep for 3 seconds and then comet h.reset. So if it animates once and then it sleeps for 3 seconds and then it animates again, then we'll know that the draw count did get changed back to 0. Okay. Sure. Well, ran once. No, seems like we made it past 3 seconds. And it did not start over again. What if instead of reset, just said draw count back to 0? Yeah, there we go. We can always just manually set it back to 0, and that'll cause it to be able to go again. Oh. So it's ending up paused actually partway through. 316 is not the right number. Hmm. Let me look in the code for animation. This feels like a fairly hacky way to try to do what we want. I wonder if animation has something that might be better for this. A cycle complete. But we saw that cycle complete was always false. That feels like the more correct way. Feels like the more correct way to do it. Have fill. We could fill it back to empty. Like turn everything off. Cycle complete. Add cycle complete receiver. So can we say commit h.add cycle complete receiver? Whoops, is it EI? Mess that up. Yeah. We'll say on complete function that we are going to define f on complete print completed. And maybe we'll also go run animation is true and global run animation and also run animation is false. I just got a page down accidentally. So then what if this said if run animation? Do that. So if it calls this function, it will print that it got completed. It will set this to false. Therefore, it will stop running the animation. Let's see if that works. Okay, so it did run only once, but zero positional arguments, but one were given. And it did not print our stuff. Back in the code again. I've never actually used this cycle complete thing before. I wonder if there's an example of it. Like it. I wonder if it's the sequence here. I wonder if sequence has a way to tell what which one's currently running. Maybe we could have a sequence with the one we want and then just a dud one after that, and then maybe we can check the current one in the sequence. Current, but it is private. Animation. So maybe our problem is just this is trying to be expecting the animation also. What if we just added animation here? That might do it for us. We'll save that. And we'll restart this. Yeah, there we go. This is expecting a parameter. So once we added that, then we're good to go. And it did print completed cycle, put run animation to false. So then if you wanted to start it again later in the future, like for instance, if the person got another correct answer, we could maybe just verify this will work. We could wait for 3 seconds. Well, that's not going to do what we want though, right? Because we're never going to leave this function. I think it's all right. We don't need to test it. I think it will work how I'm thinking once we get it into the math program. Yeah, I think it's gonna do what I'm thinking. So let's start bringing this over. Need some things imported. Instead of run animation, I'm gonna say run correct animation. And I'm going to start it on false because we don't want it to be running when we very first start the program. I'm going to set up my functions def on correct animation complete. Animation. Maybe I could do this with one function. I think I'm going to do 2 though. because I could maybe compare one that's getting passed, but I think it's going to be nicer to just have two functions. When this is completed, let's print for debugging. And then set this back to false. And or should we just use the state? I think we could just use the state, actually. Yeah, I think so. So what if we go not this Boolean? We do need global current state. And we're going to say current state is after the correct animation gets complete, the current state is going to be it's going to go back to waiting for answer. So let's just work on the correct animation first, and then we'll come back and do the incorrect one afterwards. I guess maybe we could put this down with our other function here. Okay, we're going to set up the pixel map. Call it something different, I think. We're not using both horizontal and vertical, so I'm not going to bother putting horizontal in the name because it feels more like vertical to me, but it's kind of just how you think about it. We're going to say this is the pixel map. And we're going to call this, instead of comma H, we're going to call this the correct animation. We'll add the listener. Okay. Split that down to the next line so we keep it all on the same screen. So we created our animation, we added the receiver function. So now when they get the correct answer, we want to set the state to state answer correct. And we would basically say elif current state is answer correct, then just animate. If we're in the answer correct state, then we're going to call animate. It's going to get called over and over again because we're inside our main loop. Once it finishes one cycle, it's going to call our function, which is going to move us back to the waiting for answer state, which should then stop it from any further animations, since we only have animate inside of the answer correct state. I think that logic is right. I'm gonna save this. I am gonna save this as a new name. And then I'm gonna put this back as CodePy. Yes, and before that runs, actually, I need to take just a quick break. So I will be right back in just a moment, and then we'll run this and see how it goes. All right. It looks like it crashed. Oh, nice. Got the old funhouse going here. I like those, I don't know what those are called. Neo key, the strips of 4 that are, that have the 4 keys on them. Those were out of stock when I placed my order, unfortunately, though. But I wanted to get some. I really like the way they connect with I2C, and you can chain them like that. It's looking pretty cool. All right. So what do we got? Board is not defined. That's pretty easy. We can just import board. Perhaps we didn't import board yet. I guess the reason why we never imported board is because inside MacroPad library it was setting everything up for us. Okay, pixel wing horizontal. Like every time it crashes, it's putting that like square bracket D. I don't recall seeing other devices do that before, but oh yeah, there you go. Neo key 1x4. Yeah, this thing's like, are those in stock? Self though, if they're in stock now. Stock by the time I get off of here. I'm a little impulsive sometimes. Stream and chase these things a little bit, but Neo key. Whoa. Interesting. I never saw this before. Are these connected? I mean, I see they're made to be breakaway though. Huh, that's kind of cool. Find the 1x4. Go, go. Now it's still out of stock. You know, the other thing that I wanted to get that was not in stock in my last purchase was the rotary, I don't know what it's called either. Rotary I2C? No, rotary, this thing right here. Still out of stock. I think this is really cool. The rotary breakouts that are on I2C just for plugging into any old random project and chaining together like that. But gotta wait for him to come back. All right, where are we at here? So it said pixeling horizontal. Probably I just didn't change the name of something, I'm guessing, right? Pixel map. That. Run. NeoPixel in use. Be a problem, I guess. So I think the issue most likely is that the MacroPad library is trying to initialize the NeoPixels, and we are also trying to initialize the NeoPixels. Let's see. Oh dear, there are too many things called MacroPad. All right, well, let's do it this way. Okay, probably this. Self._ Republic one? Okay. The property. So can we say MacroPad.pixels? Right, capitalization or something. Or I just did it out of order. I see. All of these things after. So they're up as well. I need to go through and this code up a little bit. All just thrown in there. And, Well, might not be able to do this. It seem like it wants to let us use sequence-like object. I mean, a sequence-like object should have length, I would think. Light. Say map light. Map based on order. If we gave this a length, it might just work. I know we're diving pretty far into the weeds on this, but I'm kind of curious. I am going to try this out. I don't know. And just make a fork, I think. Ooh, get the whole thing copied. To declare a length. Look that up. Okay. Where was that class? Or is it underscore length? Or len underscore? Well, let me catch up on the chat here. Nice, yeah, thank you guys. Thank you folks, rather, for the link there. Oh, yeah, so you got a good deal. Got the discount on them. Nice. Hey there, XOR. I don't know if you're watching the stream, but if so, thanks for tuning in. I guess you probably are. Let's Python custom object fine. We've actually done this before. Okay, yeah, that was my guess. So, of course, this is the question. Why don't we look at the answer? Yeah. That's what we want. So if we said len self, come on, there we go. Return len of self dot pixels. Might be all we need. Let me copy out of here. Not gonna run debugger in CPython, so that. Copy. not crash, and it did just do what it was supposed to do, which is create the first one of these. Unfortunately, I do not know the answer to that. We need to get it correct in order to test this out, so let's just cheat a little bit. 9. Yes, we've done it. All right, let's add an incorrect animation as well. That will be red, but it will basically just be the same animation, just a red color instead of green. So we'll say we want both of these. Yeah. Thank you. Love it when it's always fun, like, trying out stuff you've never done before, and like it's a little bit harder than I thought it was gonna be. It's because I'm not used to the way that this on-complete thing works, but it's always so satisfying to get stuff to work like that. It's one of the things that keeps me coming back to programming for sure. Keeps me interested in all kinds of programming. The feeling of figuring something out is so satisfying. Okay, so incorrect animation, we're gonna go red. Here. And we want a different function. It's gonna be very similar. Oh, we should probably PR this, I guess, too. I just kind of hacked this code in here. I want to make my incorrect animation. Let's do the incorrect animation, and then after that, I'll stop working on this project a little bit. We'll PR that change to the MacroPad library, and then see what time it is at that point. Might wrap it up after that. But let's go find this. Whoa. Can you just change the color? Let's try it. Oh. Well. So the thing is, no, this logic would be the same, wouldn't it? Yeah, actually. Let's try it that way. Let's try it that way. I like that idea better. So on, we'll call this just on animation complete. Get rid of these. Let's change this name here. Let's call this something different as well. So we'll call this answer animation. And we can default it to green, that's fine. What we'll do is here we'll say answer animation.color green. This one will be red. And theoretically, we're going to have the same logic inside these two states for now. But that's all right. I'm going to leave them separate. Yeah, I would just do the same thing inside of here. Okay. Yeah, because inside of here is where we choose the next problem. So since we don't do that here, we would start animating. Once we get our callback, we would go just back to waiting for answer. So is that all we need? I probably failed to change the name of something somewhere. So let's do correct first. So 26. Okay. Got that one correct. Our next one is 20 plus 42. Let's get this one incorrect. So 62 is the real answer. Let's say 61. We didn't get anything. Oh. Right here. This needs to be incorrect. Okay, so we'll get this one wrong. 80 minus 67, so 13 is the real answer. Let's say 12. Yep, there we go. Nice, yeah, good call. Thank you, Dexter, for the heads up there in color. And so now if we got it, well, let's go incorrect again, actually. Let's say, make sure that runs twice, and it did. So now let's get it correct, 13. There we go. Correct. All right. So I'm going to save this. I guess I already saved it because it's running, but anyway. And I think I'll stop on this code for now. There is still some more stuff I'd like to do with it, like the settings, I think is really the last... I think so, yeah. I think the settings is really the last major feature that I would like to add to this program. So the settings will make use of the rotary encoder. You'll scroll through the list. You'll change all the settings and different stuff. But we got about 20 minutes or so until I'm going to call it a day. So why don't we, since we figured out how to modify that MacroPad code, I think we should PR that so that other folks can use it as well. So let's do that. Let's get some of this stuff out of the way. Okay, and so where did I clone that from? Let's start there. Git remote-v. This is on foamyguy. Let me rename it. Git remote. Can you name your remote when you clone? Does anybody know if I can do like git clone foamyguy and then paste the URL? Will it choose the name other than origin? I don't know if that question made sense, but anybody knows if that's possible. Git remote rename origin. That's not how you spell rename. Origin. We want to name it foamyguy. Okay. Now we should have, yes, we need to make Adafruit as well. I guess we don't need to right this second, but I will eventually need to, so we might as well just do it now. Git remote add Adafruit. Adafruit. Just check on it. It's good. So now we want to go fetch, git, fetch. Nice, MacroPad for work. Yeah, I use, I'll show you what I use. Well, I have my, the MacroPad that I made on the Feather. I streamed about that a little while back. I use that sometimes, although I may switch over and start using this. I really like clicky keys, so I can see myself using this one. But what I have, my normal thing is this Nostromo N52. This thing is super duper old. I had this when I was a kid to play games. But I started using it for programming. Oh wow, these are actually pretty cheap. I should buy another one. I have a newer one as well that I have not even, it's still in the box. I have not actually used it yet, and that's my backup for the day that this thing finally dies. But I have this thing like kind of on the left side of my keyboard here, and I have a bunch of the keys set up for like copy paste. Those are the ones I use most. Copy paste. I have a run key that runs from PyCharm. It's like Shift F10. I have a save key. I have a delete key. I have an enter key. have an Alt tab, got some other stuff in there, and I'm super used to using that now. This thing's really cool. I will say though, the software for this thing only runs on Windows. So when I made it, when I made the leap over to Linux, I had to figure out something else. And the thing I use now is this evdev remap keys. It basically listens for this one HID input coming from this device, and by default, this thing just sends like the regular keys like QWERTY, like tab, Q, W, E, R, caps lock, A, S, D, F, or whatever. It sends those keys, and this evdev remap thing like listens for the keys coming from that keyboard, and then lets me consume them and then eject my own whatever macro stuff I want. So I had to reconfigure it using that thing instead of the real software for it. But it's super duper nice. I would not, like if I go to the office, I've been working from home for a while now. And if I go back to the office and I don't have it, I'm always like lost. I'm trying to use it and it's not there, and it's a bummer. So I definitely relate there on the MacroPad for work. Big help. Yeah, that thing's really cool. So let's say we want to go fetch Adafruit first, because we're gonna want to make a new branch from Adafruit main, and then git checkout -b. The name of this branch is len pixels. It's coming from Adafruit main. No track. Okay. And I already added the code here. So I don't think there's anything else we need to do. I guess it would be good, probably be good if we added a example, maybe. Make a new file. MacroPad LED animation example. .py. Yep, we want to add it. I'm just going to take the simple test from LED animation and kind of mash it up with the simple test from MacroPad, and then as long as that works, then that's what we'll do for our PR. We won't mess with like the cycle complete and all that stuff I'm using in this math example. Go here. Simple test. Start with this. PyCharm now, though. Let's see here. We're not going to need board. We're not going to need NeoPixel because this is actually coming from inside MacroPad. We will need some of the stuff from here, though. I forget the order. It's going to want a specific order once we run pylint, but I like blue better than red, so we're going to change it to blue. Yeah, we don't need to do any of this because MacroPad's taking care of it for us. And so here it was macropad.pixels. Might be it. Let's make sure this works. I'm going to go save this again as my math practice. Replace it so we have the latest version. I'm going to close these so I don't accidentally change anything else. Code. We already saved this over there, so we have a backup. Save this now. Yep, that is working fine. Okay. Can I undo back to this? I think that. Save that back to my math program. Need anything else in here? Pretty self-explanatory, I think. Could change copyright, I guess, since I wrote this. Matter that much, but I'm not getting paid to do this. I think that's supposed to be how the delineation for this works. I feel like I saw somebody say that somewhere for sure, but okay. Run pre-commit. Run all files. Got to reformat. That's what it did. Can't tell. Oh well. So we could do like undo or something. It really doesn't matter that much though. Just run it again and make sure. Good. Pilot passed. Need to do anything else? I don't think so. We're good here. Let's close this stuff. Must have control click to board to get into that. So now we are ready to push this. Implement len side of MacroPad.pixels. We'll just leave it at that, actually. Let's leave it at that. I'll put in the PR, more specifically why we did that. Make the commit message that big, though. So, commit, and we do not want to push to Adafruit. See, this no track doesn't seem to be working for me lately. It used to be when I did no track, it would be good about, like, prompting foamyguy always as the thing it went to, but maybe it's the difference between origin foamyguy. I started changing origin over to foamyguy. Anyway, though, I just have to be good about checking it before I push. This is brand new. This just has the new length function. We didn't change anything else. Push. Yeah, I mean, it feels lazy. I don't know, though. I mean, anything that saves time like that, I'm all for, like, increase in productivity. And get more done. And the other thing, honestly, is, you know, it's better for your hands and stuff, right? Like, if you can take, you know, 4 or 5 keystrokes or more and get it down to just a single keystroke, like, it might not seem like much on the surface, but, you know, typing and using the keyboard and stuff, like, that's wearing down your body, you know, a little bit. And so if you can save that kind of stuff, like, you know, that's helping your longevity as well. From like repetitive stress injury type stuff. So, yeah, I would say, you know, it may feel like being lazy, but I don't think so. I think it's like, it's definitely a good thing to try to limit the amount of repetitive stuff. So if you can cut out a bunch of the same thing and get it down to a single key, like, it's nothing but good in my mind. So this should have pushed. And yep, we have a branch with recent pushes. We'll go back to Adafruit, make a pull request. We'll give it a different name. Say, compatibility with LED animation library. Change implements lane side of MacroPad. The MacroPad.pixels object which allows it to be used with animation library. Out its code and to use it with animation is an exception. So added a basic example that illustrates usage with animation. Okay, let's double check the changes. We added length, we added this whole animation example. We could go ahead and throw in maybe new example successfully my macro device have also tested more complex animation inside of a separate project. Found it to be well. All right. We'll create the pull request. I'm gonna run the actions. Yeah, it is gonna run. Okay, I was gonna say if it needs to be approved, then I'll wait for that and hit the approve so that it runs the actions for me. But I don't know, somehow it decided to run them because I mean we saw that pop up before. It said this is my first contribution to this library, which usually that's been like making it have to be approved. Maybe it knows because I'm part of CircuitPython librarians. I'm not sure how it would have known to let it run, but whatever. Seems to have figured it out. So I think what I'll do is just hang out for one more minute while this runs the actions, make sure everything is good. If the actions do fail, then I'll try to fix them up real quick. But otherwise, as soon as we get the green check here, then I'll call it a day. But hopefully, I think what I'll try to do is get the settings page inside of this math program. My goal is to try to get that done maybe before Wednesday, and then this week on Show and Tell, maybe I'll go on there and show off this device. See if maybe they want to have a learn guide or anything for it, or if I just publish it on my own. If not, we'll see. Maybe I'll get some running around to do today, but maybe I'll jump back on the stream either later tonight or sometime tomorrow. If I end up working on it again this weekend, maybe I'll try to finish up that settings page on stream. I'm not sure if I'll end up having time or not, but that'll be kind of my goal, is to try to get it wrapped up by Wednesday to have that settings page. Yeah, for sure. You're welcome. Yeah, it's a really neat library. I know I was kind of struggling with it for a minute there to figure out how to do the on-complete thing, but I think that's a relatively like more advanced thing to try to do with that library. The majority of people who use it want it to just cycle, over and over indefinitely. So a bit of struggling, but we got there. But it is a really cool library that makes it super easy to do all kinds of complex animations. All the rainbow stuff is really fun to play with as well. I know in this one I just wanted red and green, but there's all kinds of neat rainbow ones that are super fun to play with also, if you have LED strips or grids. Maybe one day Maybe one day on the stream we could make a new animation for it. That might be a fun exercise to do. I've never done that before, but I do understand that it's relatively easy, like just overriding animation and kind of filling out how you want it to work. It looks like we passed though. We're good to go. I think oh, I came back and it went back to yellow. Refresh though, and now it's back to good. Okay. We'll do a request review. My guess is probably Kenny's probably the one who's most likely to look into this, and that'll be sometime next week. Kenny off for the weekends. We'll just tag the librarians there. If anyone does have a MacroPad and is interested in trying this out and leaving a review, you can definitely do that. That'd be super cool. Definitely appreciate that. But if not, then I'm sure Katney will get to it sometime next week or whenever she's got time. But anyway, I think that's going to be it for today. Thank you all. Dexter, Doctor, Neradoc was around, Xor674, Johnny. I got everybody. If I missed anybody, then I apologize. Thank you as well, though, for tuning in, whoever you are, if I missed you. And yeah, I will, you know, as always, I'll be back for sure next week, Saturday, 10 a.m. Oh, I should mention, actually, on the, in August, on the 15th, which is still it's a couple of weeks away. So next week is the 25th, the week after that is the 1st, and then the 8th, and then the 15th. On the 15th, I will not be, oh, got it merged already from Lady Ada, so that's cool. Anyway, though, on the 15th, I will not be streaming. I'll be taking that day off, so we'll have a week off. Maybe I'll do, I don't know if I'll do the Sunday or something. I'm going out of town to a local little town to hang out for the day, so I will not be around on the 15th, but every other Saturday, 10 a.m., as long as I don't have anything else going on, then I will be here at the normal time. So for now, I will say goodbye, and I will catch you all next week at the same time for sure, Saturday, 10 a.m. Thank you, everybody.